This is section 1.2, reviewing linear functions and linear modeling, part A. When we talk about a linear function, really what we're looking for is a function where the variable is only raised to the first power, or in general, we can put the function in this form, y equals mx plus b. This is called the slope-intercept form of the equation, and the m, the slope, can be picked out from it, as well as the y-intercept, the b. Let's talk a little bit more about the slope and the y-intercept. The slope of a line can be found two different ways, really. Algebraically, if you're given 2 points on the line, we can use our slope formula, m equals y2 minus y1 over x2 minus x1. Or, if we actually can see a graph of the line, we can count the slope by thinking of the slope as the rise over run. The y-intercept can also be found either algebraically or from a graph. Algebraically, I like to find the y-intercept by getting values for an x and a y, in other words, 1 point, and then finding the value of m using one of the methods we looked at above, and then just substituting those into the equation, y equals mx plus b, and then solving for the only unknown, which would be b. We can also locate the y-intercept quite easily just by looking at the graph of the line, although unless the y-intercept happens to be an integer, isn't always as helpful. Let's look at a few examples of equations of lines and graphs of lines. In the first example, we'd like to find the equation of the line that has slope negative 2/3 and contains the point 6, 1. We'll graph the line and we'll find the 0 or y-intercept of the linear function. So first of all, let's find the equation of the line. I'm going to start with y equals mx plus b. And I definitely know a slope because I was given m, as well as an x and a y from the point that I was given. So I'm going to substitute all that information in. Y is 1, m is negative 2/3, x is 6. And then I can just solve that equation for b. 1 equals negative 4. By the way, remember that with fraction arithmetic, if you're not wild about doing that by hand, you can always do it on your calculator. Plus b. Adding the 4 over gives me b equals 5. And so I know the equation of my line is y equals m, which we were told is negative 2/3, times x, plus the b value of 5. The next thing we're asked to do is graph the line. So once I have the equation in that slope-intercept form, I'm going to start by graphing the y-intercept. The y-intercept here is the 5. Then I'm going to use the slope as the rise over run to get more points. If I think about my slope of negative 2/3, rise over run would say negative 2 for the rise, go down 2, and 3 is the run, so go to the right 3. And I'll do that a couple of times. From the point I had, I'm going to go down 2 and to the right 3, and there's my next point. I can do that several times. Down 2 to the right 3 puts me here. And let's go one more time. Down 2 to the right 3. Once you have several points graphed, you can just kind of freehand draw, or if you've got a ruler, you can of course use that, but we're going to go ahead and sketch the graph of this line. The last thing we were asked to do was to calculate the 0, or the x-intercept. Again, just a reminder, when you calculate intercepts, whatever intercept you're finding, you set the opposite variable equal to 0. So to get the x-intercept, I have to set y equal to 0. So, using the equation that I found, and putting 0 in for y. I'm going to say if I bring that 2/3 x over to the left side, it becomes positive 2/3 x equals 5. And I'm going to divide both sides by 2/3, which is actually just the same as multiplying by 3/2. So I would get 15/2, or 7.5. That's my 0, my x-intercept, at 7.50. And notice, although we can't read it perfectly off the graph, the x-intercept in here certainly is between 7 and 8. Just looking at the graph, I wouldn't necessarily know whether it was 7.3 or 7.4 or 7.5, but I've been able to algebraically determine that it's exactly 7.5. All right, let's look at another example. This time I was given the equation of a line, or I want to find rather the equation of a line that goes through 2 points. So I wasn't given the slope, meaning that's the first thing I need to do is calculate that slope. So let's take m equals, and I'm going to subtract the x's, 8 minus -1, divided by, subtract the y's, 5 minus 2, gives me 9 divided by 3, or a slope of 3. To find the equation of the line, y equals mx plus b, I'm going to use one of my points. It doesn't really matter which point I choose for the x and the y, but I tend to make less mistakes if I go with positive numbers. So I'm going to use the 5 and the 8 as the x and the y. And of course we just figured out the m was 3. Plugging those numbers in, 8 equals 3 times 5 plus b. So 8 equals 15 plus b. And that gives me a b value of -7. So the equation of the line is y equals 3x minus 7. In order to graph this, once again, I'm going to start by graphing the y-intercept because it's a pretty easy point to plot. -7 for this line. And then my slope. My slope is 3, which I could actually write as 3 over 1. In order to see the rise over run, I need to go up 3 and to the right 1. So from the point that I started at, I'm going to go up 3 here. Oops, sorry about that. I shouldn't have drawn the point there. Let me try that one more time. I'm going to go up 3 and then to the right 1. And there's my next point. I'll continue to do that a couple more times. Up 3 and to the right 1 puts me here. And again, here. One more time there. And that's pretty good. I'm going to go ahead and draw that line. Okay, lastly, calculating the 0. The 0 is really just the x-intercept, just the x value of it. So once again, when I find the 0, I'm thinking, okay, basically I'm just being asked to find the x-intercept. So I'm going to put in y equals 0. In this case, that would be 0 equals 3x minus 7. So 7 is equal to 3x, and x is equal to 7/3. Is the 0? Once again, notice that would be what, about 2 1/3, I guess? If you look at the graph, it does indeed cross between x equals 2 and x equals 3, although I wouldn't have been able to verify that it was exactly 2 1/3 unless I had done the algebra. All right, in the next example, we're given a linear equation, x minus 5y equals 15, and we're supposed to write it as a linear function. When I have to write it as a linear function, I want to first of all get it into its slope-intercept, or y equals mx plus b form. That'll be my first task. Then I'll be able to fairly easily graph it and calculate the 0 just like we've been doing. So if I start with the equation I was given, x minus 5y equals 15, and my goal is to get y by itself, I'm going to begin by subtracting the x. So negative 5y will equal minus x plus 15. And then I'm going to divide by negative 5. But just a little reminder here, be really careful of your algebra on the right-hand side. That negative 5 is going to have to divide into both terms. And when I take negative 1x divided by negative 5, negative divided by negative is positive. And so I could write that as positive 1/5 x. The 15 divided by negative 5 will give me negative 3. That's my y equals mx plus b form. If I want function notation, I simply have to change the y to an f of x. And there's the linear function. All right, let's go ahead and graph this. The b, the y-intercept, I can see from my function notation here, is going to be the negative 3. So I'll start by graphing that point. And then the slope of 1/5 tells me to go up 1 and to the right 5. So up 1 to the right 5 puts me there. And one more time, up 1 and to the right 5. I've only got 3 points before I kind of ran out of space. So if you'd like more points, you can also go the other direction. Instead of up 1, right 5, you can think of down 1 and left 5. Notice that slope-wise, a slope of negative 1 over negative 5 is the same as positive 1 over positive 5. And so we're taking advantage of that fact in what we just did. And I'm going to sketch the graph of the line. There it is. And in this particular case, the 0 must be bigger than 10 because I can't see it yet on the graph, but we can still calculate it. The x-intercept, or 0, we'll plug in again y equals 0. So 0 equals 1/5 x minus 3. Adding the 3, I get 3 equals 1/5 x. And multiplying both sides by 5, I get 15 equals x. So I guess I was asked the 0, so I won't put it in coordinate form. I'll just leave it as x equals 15. And notice that definitely is larger than the points that I can see on the graph, which makes sense. That's why I didn't see the x-intercept when I drew the graph. In our next example, we're going to kind of reverse things here. I've been giving you information or equations and asking you for graphs. In this example, I'm giving you a graph and asking you to find the equation, as well as calculate the 0. We all know that 2 points determine a line. In fact, in one of our previous examples, we did find the equation of a line from 2 points. So that's probably a good way to go here. Let's start by identifying 2 points that are on this line. Be careful with these. You want to make sure the points you pick are easy to read, meaning you're going to want them to have integer values. You don't want to have to estimate fractions. And secondly, it can be a little deceiving. Look really closely and make sure the points you pick are exact integers. They go through the corner points of the grid. It certainly looks to me like 0, 9 is going to be one of our points. So I'm going to start with that one. And then it looks like I miss the next couple of corner points all the way until I get to 4, 4. That looks to me like the next one that goes through exactly. Now based on those 2 points, I could write out 0, 9 and 4, 4. And I could do the whole problem algebraically, calculating the slope, y2 minus y1 over x2 minus x1, and calculating the y value, the y-intercept value, like we've been doing. But actually, a whole lot easier would just be to read the information that I need off this graph. So let's start with the slope. From a graph, slope is rise over run. And if I think about what I would have to do to go from my first point to my second, looks like I would have to go down 3 units and to the right 4 units. So my slope would be down 3, that's negative 3, and to the right 4, that's positive 4. I would have a slope of 3/4. The next thing I need is the b value, the y-intercept. And once again, that's pretty easy to read off the graph as long as it's a whole number. It's not a fraction. In this case, it's right here. Oops, I think I said 9 before. I wasn't looking carefully enough. It's actually 7. And so I can read both the slope and the y-intercept off my graph. And I can now write the equation of my line. Y equals m, which is negative 3/4, x, plus b, which is 7. As far as finding the 0, or the x-intercept, I can see on the graph that it's somewhere between 9 and 10. Looks like it's closer to 9, in fact. But once again, it's a fraction. I can't just guess. So let's calculate it. To find the 0, or the x-intercept, I plug in y equals 0. I'm going to add the 3/4 to bring it over to the left side. 3/4 x equals 7. And if I divide by 3/4, that's actually the same as multiplying by 4/3. And x turns out to be 28/3, or 9 1/3. So the 0 is 28/3. 9 1/3 certainly again seems reasonable. We were guessing it was somewhere between 9 and 10, in fact, closer to 9. All right, so that's kind of graphs and equations. I'd like to talk a little bit more about what the slopes are telling us, discuss the concepts of slopes. So in general, when I think about a positive slope, that always means that my line is going uphill as long as I read the graph from left to right. And that is really important. We always read graphs just like we read words, from left to right. So a positive slope would mean the line is going uphill from left to right. A negative slope just means it's going downhill. Again, as I think about reading my graph from left to right. And to use a couple of the words that we talked about in the last section, another way to say that the graph is always going uphill is to say that it's increasing. The downhill slope, or negative slope, tells us that the graph is decreasing. All right, so that's one thing slope tells us, the direction of the line, increasing or decreasing. The second thing the slope tells us is the steepness of the line. If the absolute value of the slope is very large, the line's going to be very steep. A line with slope 5 or 6 or 7 is a pretty steep line. If the absolute value of the slope is small, a fraction like maybe 1/3 or 1/4, the line's not very steep. So the steepness is also determined by the slope. Let's think for a moment about a slope of 0. If you think about slope as steepness, and you have 0 steepness, what would that look like? Well, 0 steepness would be completely flat. It would just be a horizontal line. If the slope is undefined, that actually tells us we have a vertical line. I'm going to sketch that and then talk about it just a little bit. Once again, if you think about the slope as the steepness, Hopefully it kind of makes sense that a vertical line, it would be impossible to assign a numerical value for the slope or steepness. Because if I tried to, I would always be wrong. That line is really, really steep. What if I said, let's call the slope 1,000,000? Well, the problem is there would still be a steeper line, a line with a slope of, say, 2,000,000. So it's impossible to assign an actual finite value for the slope of the steepest possible line, or the vertical line. In the next set of graphs, we're going to just subjectively decide whether the slope is positive, negative, 0, or undefined, and therefore whether the linear function is increasing, decreasing, or constant. And then if the slopes are positive or negative, we want to know if the value of the slope, or the absolute value of the slope, is relatively small or relatively large, at least in comparison to the other examples that we're showing on this page. So in A, we definitely have an uphill slant to that line, and so we can say the slope is positive. This line, or this linear function, is increasing. And compared to some of the other lines, like for example D or F, this is not very steep, and therefore I'm going to say M is relatively small in comparison to the other lines. B is a horizontal line, so there is 0 steepness, meaning our slope is 0. And we often call this a constant function because the y value stays the same at all times. In this particular case, it's always 3. Part C, we've got a decreasing line, or a downhill slope, so our slope would be negative, and the function again is decreasing. Once again, in comparison to the other lines we're going to look at in examples D and F, this is not a very steep line, so I'm going to say it's a relatively small absolute value of the slope. Probably should put absolute values on there. All right, D, once again, we would have a negative M value. It's downhill. It's a decreasing function. But we now have a line that's quite a bit steeper than it was before. So relatively speaking, the absolute value of the slope here is going to be fairly large. E, we have a vertical line. So the slope is undefined. We don't give this function any special name, and we can't really say anything about slope because slope is undefined. So we'll just simply say slope is undefined on that one. In F, we've got an increasing function, goes uphill from left to right, so our slope is positive. And once again, it's fairly steep compared to the other examples, so I'm going to say the absolute value of the slope is relatively large. I want to spend just another couple of minutes on the two special cases, the horizontal lines and the vertical line. It's possible to find equations of those fairly easily because in each case, one of the variables never changes. If I look at graph B, every single point on that line has the same y value. Every y value is 3, or no, 4 actually. And so I can say that the equation of that line is simply y equals 4. In graph E, the vertical line, once again, every single point on that line has something in common. Every single x value for points on that line is 2. And therefore the equation of the line is simply x equals 2. So horizontal and vertical lines have especially simple equations. If you'd like to go ahead and do some practice problems on graphing lines and finding equations of lines, I'd recommend that you pause your video or stop your video right now and go ahead and try the problems on the next couple of pages, checking the answers with the posted solutions in my math lab if you'd like to do so.